My name is Stuart Reid, Chief Technology Officer at Testing Solutions Group, and in this webinar I will introduce you to the new set of International Software Testing Standards being jointly produced for ISO, the IEC and the IEEE. Back in May 2007, ISO formed a working group to develop a new set of standards on software testing, a brand new area for ISO. I was, and still am, the convener of this working group. This initiative was closely supported by the IEEE and BSI, both of which have donated existing testing standards to the project. These standards will be retired as the new ISO standards are published. If you're involved in testing, then these new standards should affect you. The first three were published at the start of September 2013, and even if you don't choose to use them, and are not required to use them by your client or employer, it will still be useful to be aware of them. After all, you may have to justify why you aren't using them. Please note that the individual standards are mostly numbered as parts of 29119, and although officially they are all triple badged as ISO/IEC/IEEE standards, to make things easier from now on, I will simply refer to them as ISO 29119. This webinar will initially introduce the purpose of standards in general, as there are quite a few widely held misconceptions on what standards are for. Next, we will look at why there is a need for internationally recognized software testing standards, followed by a brief look at how they have been developed. The main part of the webinar will cover what standards are included in ISO 29119, their content and how they are related, how these standards apply to your work, the current status of each of the standards, and details of how you can get involved will be explained at the end. According to ISO, standards are, quote, guideline documentation that reflects agreements on products, practices or operations by nationally or internationally recognized industrial, professional, trade associations or governmental bodies, end quote. Note that they are guideline documents, as they are not compulsory unless mandated by an individual or an organisation. So, although there is a widespread perception that standards are imposed on people and organisations, in fact that depends on how they are used. If specified in a contract, and the contract is agreed by both sides, then they can mandate requirements. But obviously this depends on the agreement reached by the users. Standards are based on agreements because they reflect a certain level of consensus. ISO defines consensus as, quote, general agreement characterized by the absence of sustained opposition to substantial issues by any important part of the concerned interests, and by a process that involves seeking to take into account the views of all parties concerned and to reconcile any conflicting arguments. Consensus need not imply unanimity, end quote. So, just to be clear, everyone on the working group does not have to agree with everyone else. In practice, when developing testing standards, it is safe to say that unanimity is in extremely short supply, whereas the need for reconciliation is plentiful. As you may guess from the prolonged development period for some of these testing standards, the working group certainly did not simply agree on the first drafts, and I think it is safe to say that no one agreed with every part of the resulting standards. But it would be safe to say that everyone working on the standards got plenty of good practice at compromise. Studies on standards in general, that is not just testing standards, have shown they provide increased productivity and profitability for businesses of all sizes, and perhaps more surprisingly, enhanced innovation, probably by focusing innovators on those areas where innovation will be most productive. Standards provide consumers, in our case those who pay for the testing, with increased confidence in organisations that can show compliance with standards, as they know that the standards have been developed by expert authors. These same organisations benefit from basing their practices, in our case the actual testing, on agreed industry standards rather than having to create their own in-house processes from scratch. In short, standards afford benefits to both the consumers and the providers of testing services, as the authors of the standards provide their expertise to a transaction that would otherwise be lacking. A common misconception with standards is that they define best practice. This is obviously not a sensible approach, as only one organisation or person can ever be best at any one time. There is only one gold medal for each Olympic event, and we all know that there is no one best approach to testing. It should be context-driven. If standards defined best practice, then most of us would not even bother trying to achieve this unattainable goal, knowing it was probably too far away from our current situation. Instead, standards should define good practices with the aim of providing an achievable goal for those many organisations whose current practices are deficient in different ways. What standards can provide is a current definition of an industry's accepted body of knowledge, and so provide the foundation, or at least a stepping stone, for testing to become recognised as a professional discipline. At the most fundamental level, they can define a common terminology so that each testing term does not need to be agreed each time a new project starts, or each time a new tester joins the testing team. Defined testing processes and techniques in standards can form the basis for professional qualifications within the industry, allowing transferable skills to be recognised by different employers. And they can also be used in schemes for organisations wishing to assess and/or improve their processes. And where testing is bought, standards can be referenced in contracts to ensure that the agreed level of service being bought and sold is understood by all interested parties. A common use of standards is to ensure interoperability and consistency. For instance, in our own countries we all benefit from standards such as agreed currencies and rules for driving, such as whether we drive on the left or right and what a safe maximum speed is. Unhappily, our different histories have led to some lack of efficiencies that earlier international standardization could have provided. The ISO 29119 standards will hopefully bypass many of these inefficiencies and be used to support international testing projects and qualifications, and perhaps at some point even an international professional body. It is possible to imagine a future testing industry where qualifications are based on accepted standards, required services are specified in contracts that reference these same standards, and our best industry practices are based on the foundation of an agreed body of knowledge. This could easily be the testing industry of the near future. Unhappily, up until now, there has been no definitive software testing standard. A number of standards on some aspects of software testing have been published by bodies such as the IEEE and BSI. These have either covered testing in individual lifecycle phases, such as BS 7925 Part 2 software component testing, or covered specific aspects, such as test documentation, such as IEEE 829. Prospective consumers of software testing services cannot simply look for a software testing badge of compliance, and testers have no single source of good practice. There are many standards that touch upon software testing, but many of these standards overlap and contain what appear to be contradictory requirements with conflicts in definitions, processes, and procedures. There are some useful IEEE testing standards, such as the aforementioned IEEE 829 and IEEE 1028, and useful national standards, such as BS 7925 Parts 1 and 2. But there are large gaps in the standardization of software testing, such as in the areas of organizational level testing, test management, and non-functional testing, where no useful standards exist at all. Many organizations recognize that their current testing is not performed efficiently and needs to improve, but are wary of spending too much on informal and unproven approaches. The demand for the existing formal standards is high, and the popularity of the ISTQB testing qualification scheme can be seen as further evidence of the demand from both clients and practitioners for an agreed set of test practices, albeit these are obviously not the same as official standards. Given the apparent demand and the current conflicts and gaps, it seems clear that the best solution is to develop an integrated set of international software testing standards that provide far wider coverage of the testing discipline. And ideally, this initiative would not reinvent the wheel, but build upon the best of the available standards. Thus, the motivation for the ISO 29119 set of standards. Standards creation is managed by a large number of standardization bodies. There are several international standards bodies such as ISO, IEC and CEN across Europe, and national standards bodies such as ANSI in the US, BSI in the UK and DIN in Germany, who provide representatives at the international level. There are also a number of domain-specific standards bodies which typically cover safety-related areas. For instance, NASA, the European Space Agency and the FAA in the aerospace field. Unsurprisingly, given their dependence on IT, defence organisations such as the Department of Defence, the MOD and NATO have also developed their own standards, although the US DoD at least now have a policy of using civilian international standards wherever appropriate, and so they will be adopting the ISO 29119 standards as they become available. This means that the publication of the ISO 29119 standards will have a large impact on all defence contractors supplying testing to the Department of Defence, hence their interest in these standards. A final group of standards bodies worthy of note are those IT industry bodies that maintain standards, e.g. the IEEE, INCOSE for systems engineering, and the Object Management Group for UML. In a similar move to the Department of Defence, the IEEE now have a policy of donating their standards to ISO, thereby reducing their standards maintenance costs and also increasing their cohesion within IT standardisation. As part of this initiative, the IEEE have donated both IEEE 829 and IEEE 1008 to the new ISO 29119 set of standards. ISO, the International Organization for Standardization, comprises a network of over 160 national standards bodies and had published well over 18,000 standards by the end of 2010. The ISO Strategic Plan for 2011 to 2015 expresses a commitment to be, quote, the world's leading provider of high-quality, globally relevant international standards, end quote. In the field of information and communication technologies, ISO often collaborates with the IEC, the International Electrotechnical Commission, to produce joint standards, in the region of 1,000 so far. ISO and IEC have set up a committee, SC7, on software and systems engineering, with terms of reference for the, quote, standardization of processes, supporting tools, and supporting technologies for the engineering of software products and systems, end quote. In 2013, SC7 had 59 national standards body members. The proposal for a new set of standards on software testing was approved by ISO in May 2007 to be based on existing IEEE and BSI standards, that is IEEE 829, IEEE 1008, BS 7925 Parts 1 and 2. As no working group with software testing expertise existed within SC7, a new Software Testing Working Group, WG26, was created. By 2013, well over 30 different nations were represented on WG26, with 25 different countries represented at face-to-face meetings. The initial proposal for ISO 29119 was for 4 standards, which were implemented as 4 parts. The slide shows how existing standards feed into parts 1 to 4. Note that even though donated by the IEEE, IEEE 1008 is not shown, as the working group could not find a use for it. Fairly soon after work on the first 4 parts started, it became clear that people would want to assess how well the test processes in Part 2 were being applied by a project or organisation. And so ISO 33063 on test process assessment was created as a result of a new work item proposal. This standard is being jointly developed with ISO Working Group 10, which covers process assessment in general. Work on a separate standard on keyword-driven testing has also recently started. The underlying model used as the basis for the new set of standards can be seen on the slide, and comprises 5 basic entities, with the test processes forming the central core. The test documentation is produced as a result of executing the test processes. Thus, the test documentation describes the outputs of the test processes. The requirements to use techniques to perform the testing, e.g. designing the test cases, is defined as part of the processes, while the actual techniques are defined separately. The test assessment is performed using a process assessment model based on the process reference model defined in Part 2. The terminology used by the other parts of the model is defined in the vocabulary. Part 1 provides an introduction to the set of standards and includes the overall set of definitions for all the other parts, as well as describing the basic testing concepts on which the set of standards are built, such as the requirement to use risk-based testing. This part explains what the different parts of the standard include, and how the standard can be used by those following different lifecycle models, including both the V model and Agile approaches. Note that all ISO standards need the scope, conformance and normative references, as shown in the yellow box at the start. The processes in ISO 29119 Part 2 are defined using a 3-layer model as shown. Thus, the test processes cover testing from the organisational level all the way down through project test management of individual test phases or levels, down to the dynamic testing of the smallest software component. Worthy of note is that the lowest layer is currently specifically defined as purely dynamic test processes, and so the overall model currently does not include any static test processes. This is because it was not possible to gain consensus within WG26 or SC7 on the inclusion of static testing in this standard. This will be addressed in the next version, and static test processes are already included in the process assessment model defined in ISO 33063. This slide provides an example of how these layers may be used in a relatively large and mature organisation. That is, an organisation mature enough to have an organisational test policy and large enough to make it worthwhile having an organisational test strategy. It shows the generic processes in Part 2 of the standard being instantiated for use at different levels. The organisational test process is instantiated twice, once to develop and maintain the organisational test policy, and once for the organisational test strategy. The test management processes are instantiated to develop and implement the project test plan, and also used for each subsequent phase or type of testing for which a separate test plan is created. Although test plans developed using ISO 29119 are expected to include consideration of both static and dynamic testing, the lowest layer of processes in ISO 29119 is currently limited to dynamic testing. These dynamic test processes would be implemented whenever dynamic testing is required by a test plan, for instance for unit testing, system testing, performance testing, etc. This slide shows the complete set of 8 test processes defined in the standard. Note that there is just one process defined at the organisational level. Each process is made up of a set of activities, and each of these activities comprises a set of specific tasks. We'll see an example of a process description a bit later. As just mentioned, there is only one organisational test process, and as can be seen, it comprises 3 activities. It is used for the development and maintenance of organisational level test specifications, the most common of which are the test policy and organisational test strategy. Organisational level test specifications typically apply across a number, if not all, projects in an organisation, and so are not project specific. They ensure that a consistent approach to testing is maintained across all projects. If the organisation is large enough to run projects that are quite dissimilar, say in different programs, there may be organisational test specifications that are specific to each program. A test policy defines the scope of testing and describes the principles and high-level objectives expected of all testing within an organisation. It is expected to be a high-level document of only a couple of pages that is understandable by executives and aligned with other executive-level policies, such as the quality policy. The test policy provides guidance and constraints on the organisational test strategy and acts as a framework within which all the organisation's testing should be performed. An example of content from a test policy may be that, quote, all testing should comply with the ISO 29119 software testing standard, end quote. In contrast to the test policy, the organisational test strategy is a technical document that details the expected practice of testing on all projects in the organisation, and, as such, is expected to comprise many more pages. It must be aligned to the test policy, assuming there is one, and defines a set of reusable testing guidelines that can be used as the basis for specific test plans by test managers, thus reducing the decision-making required at their level and ensuring consistency across projects. Example content of an organisational test strategy may be that, quote, an exit criterion for unit testing should be that 100% statement coverage is achieved, end quote. There are 3 test management processes as shown. These processes are used to manage lower-level testing processes on a specific project, such as dynamic testing, as shown by the green box, static testing, not shown as currently not part of the standard, and lower-level test management, when needed, shown by the smaller blue box. When the test management processes are used at the project level, and the project is large enough, then this project test plan may require test plans to be generated and implemented for individual test phases, e.g. for system testing and acceptance testing, or for specific test types, for instance for performance testing or usability testing. While performing these test management processes, any constraints or guidelines provided by the test policy or the organisational test strategy should be complied with, unless there is a good reason to deviate, in which case any deviation should be agreed and documented. This is shown by the arrows going to and from the yellow box at the top. One of the major outputs of these test management processes is the test plan, which is used as the basis of the actual testing performed. This slide shows the activities that generate the test plan. The figure is necessarily a simplified view of the process, and although a simple linear flow is shown, in practice, a considerable amount of iteration between activities would be expected to occur. For instance, as the test strategy is designed, in Design Test Strategy on the far right, it is likely that new risks will be uncovered and old risks changed. As can be seen in the activities for identifying, analysing and mitigating risks, the standard mandates a risk-based approach to testing. It does not, however, specify the mechanism for performing the risk analysis. In a safety-related application, it could be appropriate to use integrity levels derived from perceived risks, while in less critical applications, it would also be possible for the test manager to make subjective judgments based on levels of risk that were simply asserted by the customer. One of the most important test planning activities is the Design Test Strategy activity on the far right, where decisions such as which features are to be tested and which test phases test techniques and test completion criteria to be used are made. The test strategy at this level is being derived as part of the specific test plan and is quite different from the organizational test strategy. The organizational test strategy provides generic guidelines on how to test across a number of projects, whereas the test strategy here, that forms part of the test plan, defines the specific testing to be performed on this project. Note, however, that the test strategy and the test plan should normally align with the guidelines and constraints provided in the organizational test strategy, and so there should necessarily be similarities. Although test planning is obviously an important process, test managers spend far more of their time on day-to-day management, the test monitoring and control. As can be seen, this comprises 4 activities and is largely driven by the test plan. Objectives specified in the test plan are used by the monitor activity to identify test measures, which are used to determine how closely the actual testing is following the plan, and the control activity issues directives to ensure the plan is followed, where possible. The report activity provides status reporting on the progress of the testing. Not shown here is the feedback from this process that includes updates to the test plan as needed. Moving down a level, this slide shows the 4 dynamic test processes. It should be noted that if static testing was also part of the standard, 2 of the processes, test environment setup and test incident reporting, could be shared between static and dynamic testing, as both static and dynamic testing require a test environment, and both also require incidents to be analysed and subsequently reported as necessary. The dynamic test activities are driven by the test plan, organisational test strategy, and test policy. For instance, the test plan could specify what features are to be tested, the organisational test strategy could specify that a certain test completion criterion is to be achieved, and the test policy could specify that incident reporting is to follow a defined organisation-wide incident management process. Each of the 8 processes included in Part 2 of the standard is described using the format for process descriptions defined in ISO 24774. This is an ISO rule. We had to follow it, so don't blame the Software Testing Working Group. This ISO technical report states that a process should be described in terms of title, purpose, outcomes, activities, tasks, and information items. It is worth noting that this structure includes no description of who performs the activities and no process inputs. The information items correspond to the process outputs. Note that the ISO guidelines on process description also provide many rules on the necessary wording and content. Here we can see a partial example of a process description. For the organisational test process, this is the smallest and so easiest to fit on a slide. There is a very strong link between the Part 2 Test Processes Standard and the Part 3 Test Documentation Standard. This is because the outputs of the processes defined in Part 2 generally correspond to the test documentation defined in Part 3. As Part 3 is a documentation standard, according to ISO, it must comply with the structure and format defined in the ISO 15289 standard. Hence, what might appear an unusual structure to some. But again, don't blame the Software Testing Working Group for this. The basic structure of Part 3 is shown. In practice, the annexes are expected to be of most use to actual testers and take up by far the most space. These provide examples for each of the defined test document types for both agile and traditional projects. This slide shows each of the major test document types defined in Part 3. Templates are provided with descriptions of the contents for each of them. The document names used in Part 3 are naturally consistent with the outputs described in Part 2. But there is no requirement for users of this standard to use the same document structure or the same naming. So, if you want to, you can combine or break up the documents described in the standard, as long as the required content is documented to the same level. Those users following the Part 2 test processes standard are required to produce test plans that specify which test case design techniques are to be used, as well as test completion criteria to be achieved. Test case design techniques and corresponding coverage measures are defined in Part 4, the Test Techniques Standard. Each test case design technique is formally defined in the normative part of the standard, and, probably more usefully, corresponding examples showing how the techniques could be applied are provided in the annexes. It is closely based on BS 7925 Part 2, so users of this standard will notice a close correspondence with Part 4. A notable difference from BS 7925 Part 2 is that an annex on the testing of quality characteristics, that is, non-functional testing, is also provided. This shows which of the defined test case design techniques are appropriate for the testing of each of the quality characteristics defined in the ISO 25000 or Square series of standards. At present, Part 4 includes 11 black box techniques, 6 white box techniques, and 1 experience-based technique. One of the questions we get asked most is, will these standards apply to me? The first thing to say is that they were written to be generic, and so applicable practically anywhere. Throughout their development, we have been asking ourselves whether someone doing exploratory testing could comply with the standards, and whether someone following an agile approach could use them. Hopefully, we have managed to accommodate the widest range of potential users. One way this is possible is that users of the standards are able to tailor their use rather than fully comply with every requirement if they so choose. In this case, they simply need to document their chosen level of compliance. The standards should also be useful for organisations of a wide variety of sizes. They have not been written solely for large defence contractors or financial institutions. We also get asked how these standards are useful for those testers working within a regulatory regime, such as in the safety critical area. It should be noted that the ISO 29119 standards do not tell you how much testing to do. That is, they do not mandate specific test techniques or test completion criteria. They simply mandate that you use a risk-based approach. So in the safety critical situation, we would expect users to be provided with test completion criteria from their existing regulatory standards, but then use the new ISO 29119 testing standards to help define their test processes and so structure how they actually perform their testing to achieve the required test completion criteria. If you are still doubtful about using these standards, then I have a question for you. Can you afford not to? Imagine you're responsible for the testing of an important application. It could even be business critical or safety critical, and something goes noticeably wrong with the application in use. Even if really good testing could have missed the bug, how easy will you find it to explain to the business that your testing missed the bug, and no, your test processes do not comply with the international testing standards, but they are the ones we have used for years, and no, you don't have them fully documented and justified. So, can you afford not to use them? Historically, a typical ISO standard has taken over 7 years to publish, although the rules for completion have been tightened up in recent years to try and encourage faster publication. As an example, the Framework ISO standard for software lifecycle processes, ISO 12207, was conceived in 1988 and published in 1995, representing 17,000 person-hours of effort. BS 7925 Parts 1 and 2 took 8 years to develop. Progress on the publication of the ISO 29119 standards has been slower than expected, but mainly from the perspective of SC7 as a whole, rather than from the software testing working group itself. The SC7 expectation was that as the ISO 29119 standards were based on pre-existing IEEE and British standards, their development would largely be a rebadging exercise. WG26, on the other hand, knew from the start that the core test processes standard would need to be developed from scratch, as the donated standards only provided conflicting processes for unit testing and no processes at any other level, so no organisational level or test management processes. A second factor that resulted in slower progress was that our reviewers were largely testers and, unsurprisingly, very demanding in pointing out any improvements that could be made. In the course of the development so far, we have received and taken into account and fully documented many thousands of comments, well into 5 figures, an enormous task, but also one that contributed to truly inclusive and impressive standards. As can be seen on the slide, the standards have been developed in several tranches. This was partly due to the lack of available editors to start working on all 4 initial parts at the same time. The explosions at the start of the full international standard FIS stages represent full publication. For parts 1, 2 and 3, this was early September 2013. For part 4 on test techniques, this should be in early 2014. The Test Process Assessment Standard, ISO 33063, is also due for publication next year. Part 5 on keyword-driven testing should be published in 2015. Given the high cost of testing and the maturity of the discipline, it is somewhat surprising that until now a comprehensive set of testing standards had not been developed. Apart from demand from the consumers of test services and test practitioners looking for a guide on good practice, there is also now a stated demand for a standard to act as a body of knowledge for test certification schemes. For many years, safety-related software development standards have required forms of testing to be performed and various test completion criteria to be achieved, but there has been no testing standard describing how this testing should be done, nor how the test coverage should be measured. The new ISO 29119 software testing standards should help fill this gap. The new standards define good practice for testing at the organisational level across multiple projects, at the management level, planning, monitoring and control and test completion processes, and for the processes for designing and performing dynamic testing. As well as the test processes, which mandate a risk-based approach to the testing, test documentation, test case design techniques, and a testing vocabulary are all covered by these new standards. Additional standards are already under development in the form of a test process assessment standard and a keyword-driven testing standard. In September 2013, publication of the new ISO 29119 testing standards began, providing the testing industry and their customers with an internationally agreed body of knowledge for the discipline. Testing standards provided as source documents from IEEE and BSI will subsequently be retired. These new standards are the culmination of over 6 years' work by a group of experts from over 30 countries, and I would like to take this opportunity to thank them for all their efforts and patience over that time. If you would like to get involved in the ongoing work on the ISO 29119 testing standards, then there are a number of options. First, you could join WG26, but to do so, you must be a representative of your national standards body. WG26 meets every 6 months for a 5 or 6 day meeting in a variety of locations worldwide. Alternatively, many countries have their own mirror panel that reviews drafts and feeds comments back to WG26 on draft versions of the standards. If you have managed to reach this point, you should have many questions. For instance, how did the working group justify including specific content in the standards? What are those factors that will make these standards succeed or fail? How do I apply risk-based testing in my situation? And no doubt many more. Please feel free to email me with any such questions and I will get back to you. Thanks for listening, and I hope you enjoy the standards.